Alright, welcome back everybody. Today we're going to be working with variables in Jupyter Notebook, and at the end we're going to make our very own calculator on Jupyter. So to start, we're going to go over what a variable is. So a variable is a storage location for your data in your program. Whether it's text, numbers, or anything like that, you can make your code have something equal to a letter and store it for later. For example, if you have someone's name is equal to, let's say, Bob, then the computer is going to use its storage to hold the variable of name, and that it will save whatever name you put it as. To start, what we're going to do is we're going to create a slot machine. We're going to import numpy as np. So what this is doing is this will allow us to use a couple different tricks later on. What we're going to do is we're going to make our win equal to false, and we'll make this our win check. So to start this code, what it's saying is it's going to check to see if you won, and because you haven't played yet, obviously it's going to say that it's false. So now what we're going to do is we're going to have our first number is equal to np, using the numpy from before, and we're going to have random.rand int, and we're going to have it go from 1 to 9. What this is saying is we're going to use our variable n, and it's going to pick a random number from 1 to 9. Next up, we're going to have an if statement. So if n is equal to 7, so if our random number is equal to 7, then what we're going to do is we're going to have our when check change from false to true, indicating that you won. So we'll print our number. This 7 can be changed into anything you want though. So what we want to do is we're going to make a code where we're going to have 3 random numbers picked, and if any of them are 7, then it will print that we won. Otherwise, it will print that we've lost. So our next number is, we'll use number 2. So this is our next variable, and we're going to follow the same steps from before. We're going to have random.randint from 1 to 9. And then if n2 is equal to 7, then the win check will equal true, just like before. And we'll print this number as well, just to check to see if our code's working properly. And we're going to just copy and paste this last one, because we'll have for our third number, and anywhere that's an n2, we'll change it to n3 to be our third number. Now, to check our code, we're going to have if the win check is equal to true. If win check is equal to true, then we will print that we won. So in this case, we saw that our n was 6, our n2 was 1, and our n3 was 4. So we know that it didn't work, so it's good that it didn't print win. So what we're going to do to make it a little bit easier, we're going to make it 1 to 3, and we're going to have this as 2. Because even though it says 1 to 9 and 1 to 3 here, our last number is not included. So it's actually going to be 1 to 2. So no matter how many times you rerun the code, a 3 will never show up. It will only be 1 to 2 because of the last number. So we can see that we won. But if we wanted to make it say that we lost whenever it doesn't work, we'll write else, have a double dot, and we'll print we lost. There you go. Now, if you want to make it a little bit neater, what you can do is when you have the print statements with your variables, you can put an apostrophe, and we can say this is your first number. Then end apostrophe and comma, and then at the end it will print it out saying this is your first number, then printing your first number. Next, we're going to use variables, but instead of putting numbers into the variables, we're going to put names and words into the variables. So if we have our new code here, we'll have first word is equal to birth, and we have our second word equal to day. Then when we print names is equal to first word plus second word. Then when we print it, it will say birthday. What we can do this adding, not just for words, but we can do it for numbers too. So let's say we have our number 1 is equal to 15, and our number 2 is equal to 2. If we have our sum of both the numbers equal to to n1 plus n2, and then we print our sum, what happens is it will do the addition for you. So instead of just putting the two things together, it will actually add them for you, which will tie in to making the calculator. Now that we got our sum out of the way, we're going to use a little bit more math to figure out other operations. So what we're going to have is our x is going to be our whatever they input as our x. So what this is saying is it's going to take the integer of whatever their input is, and we're going to put our operation is equal to the input, and we're going to put operation, which will tell us which operation that they want to use. Now what we can have, if our operation is equal to the plus sign, meaning they want to add two numbers, we're going to need a second number. So we need to take the input of the integer of some value that they want as y. And following this, we will have the result is equal to x plus y. And we will be able to print the result. So it will first ask us for x, which is right here, and it will take the integer value of whatever we type in. So we'll type in 14, and it will take our integer operation. Now, since we only have one operation allowed, I'll type in plus so that it doesn't break the code. And for our y, we're going to type in, let's say, 16, and it'll give us 30. Now what we're able to do is we can build onto the code to add different operations. So we don't need to change this at all. And in fact, we could take this and just copy it to use it for later. So our addition operation is done. Now what we're going to do is we're going to do our subtraction operation. So it's the same thing. If oper is equal, so instead this one's going to be our minus sign. Then we're going to ask for a y input, and we're going to put our result as x minus y. So that's our second one. Our next one, what we're going to do is our multiplication. So if oper is equal to multiplication, which is asterisk encoding, then we'll have it ask for y again, and we'll put the result as equal to x multiplied by y. And our final easy one is we're going to have if the operation is equal to division, which is going to be our slash, then we're going to have to ask for y one last time, and we'll put our result is equal to x divided by y. So now when I print it, I can put x as 15, and I want to divide by 3. I realized a mistake. For a result, we just want 1 equals, not 2, because that will mess up the code, and it will set it to that instead. So we have 15, our operation is going to be divide, and our y is going to be 3, and it will give us 5. But if we want to test it again, we could have 3 multiplied by 5 gives us 15. So we know the code works perfectly. Now what we can do is we can have a couple more obscure ones. So we can have if operation is equal to, let's say, square root. Then what we can have is we have a result, gotta make sure it's a space, is equal to the np dot square root command of x. So what this will do is it will just take the square root of the number that we want. It will take the square root of x. And our final one for today, we are going to do the exponent. So what we're going to have is if the operation is equal to this hat right here, it will say ask for a y input, just like what we've been doing. And then what it will do is we'll have the result is equal to x to the power of y. So if you want to say x to the power, you need 2 asterisks. You need 2 asterisks. So let's say we want 4 to the power of 2. It gives us 16. And we'll test our square root one. We'll have 16, and we'll ask for the square root, and it'll give us 4. So we know that our code works perfectly fine. And now we create our own calculator.